Hey everybody, my name is Alex with Hake Hardware, and in this video we are going to go over how to set up a autonomous farmer using the Ubuntu CLI. So as always, in the beginning here I have the system requirements. Check out the official wiki for requirements on running a farmer in general. And then there's some more information on GPU plotting requirements if you're going to be using a GPU to plot, which is highly recommended. Definitely check those out. And you should have already installed your NVIDIA GPU drivers. If you haven't yet, I have in the Ubuntu section here, there should be NVIDIA driver installation, so you can go and check that out if you need to. But let's get started with getting the farmer set up. So as always, we're going to do some organization here. We want to create a directory for where the farmer, let me make this a little bit larger, directory for where the farmer is going to hold the executable. And we'll also do some other things in that directory, but let's jump over to the terminal and get started. So the first thing we're going to do is create that folder. So make dir-p autonomous farmer. And what that's going to do, the -p is going to create the autonomous folder if it doesn't exist. Now, if you've already done the node, which you should have, that folder should exist. And then we're just going to go to that directory. And then we want to get the latest version. So let's jump back to the browser here, and I'm going to click on the subspace releases. And this time we're going to want to get so I'm looking for the latest tag, and I want to get the farmer this time. So I know I'm running Ubuntu x86 Skylake. So I'm going to copy that link, and then I'm going to jump back over to my terminal. I'm going to do wget-p, so we're going to specify the download directory, which is autonomous farmer. And then I'll paste in that download link, ls, and there we go. We need to make this executable. So chmod plus x subspace farmer. It's green, which means it is executable. And the next thing we're going to want to do is identify the disks that we're going to want to add to our command to run the subspace farmer. So I'm going to do df-h and then --block size --block -size equals G. And actually, can I do GIB? There we go. So it's actually the same. I just wanted to make sure that gigabytes and just G was correct, but these are going to be my two drives, and I want to specify it in gigabytes. So I'm going to say, I'm going to leave 1 gigabyte free. So I have 14305 available here, and I'm going to use 14304 gigabytes. So let's jump back over actually to our browser. And here's what the command looks like. So we're specifying our executable. We're going to say farm -- reward address, and that's where you're going to put in your reward address. This is for the metrics. Notice that it's a different port, 9081. The node was 9080. And then we're going to repeat this path for each drive that we have. So if I have just one drive, I would just delete this out because I already have a path down here with the T. And if I have more, I would just copy this one and paste it and make more entries. And then you're going to want to specify the full path to wherever your drives are mounted, and then the size. So this is where I'm going to be specifying that 14,304 gigabytes. So just like with the node, there's better ways to do this, right? We can make a script, and then we can use tmux to launch the script inside a session and then detach from that session. But I want to cover one more thing. In the case where your node is located on another PC, you need to specify the IP of the node and pass in a --node-rpc-url flag. And what this is going to do is allow your farmer to connect to a node on a different internal IP address. And if we go to the node, you also need to have extra settings. So if your farmer will be on a different PC than your node, in your node you should be adding --rpc listen on, --rpc methods unsafe, and --rpc cores all. So just a heads up, if your node is on a totally different PC than your farmer, you're going to need to do those extra parameters. But if everything's on the same computer, like in my case, then those parameters are not required. But let's actually just do the script right off the bat, because it's a lot easier for me to put everything in and kind of show you what I'm doing with the script. So we're going to create a farmer.sh script. We're going to paste in this script here, make it executable, and fill out everything that we need to. So let's jump over into our terminal here. We're going to do nano to open up our farmer.sh. I'm going to paste this in here, and let's go through and start updating some of the sections. So this is actually the correct path to my farmer executable. This is the correct path for where I want the logs to go, but I need to enter in my reward address. So I'm going to find my reward address. Take just a moment here. All right, there it is. Okay, so let me scroll down. I'm just going to erase this, and then I will put in my reward address. Now, here's where you would put your paths. So you can, again, copy and put more in if you need, or less in if you don't need as much. Now, I need to get my mount points, so I'm going to just actually do Control X, Y, and Enter, and that saves my changes. And then I'm going to copy this mount point. Then I'm going to go back in, and I'm just going to edit this, and then Control X, Y, Enter to save. Get this next mount point, and then update this real quick. And then we need, oh, I overwrote the path here. Path equals. And then we need to update this. So 14,304. So that'll give me one free Gibby byte. 14,000. If I remember correctly, that was one less Gibby byte. They're different brands, so I think it's just, I don't know. So Control X, Y, Enter. I want to verify that. 14,304, 14,305. 14,304, 14,303. So I believe, okay, so C4991 has 4. C4991 has 4. Okay, and 316D should have 3. So 316D has 3. Okay, so we got 1 gig extra. And then this command, we don't need to make any changes. Everything else looks good. Now, there could be something wrong, but it's usually not detrimental if you just go ahead and try it out. And if it doesn't work, it doesn't work. So we'll do Control X to exit out of this. I'm just going to clear this. And then we're going to create a session in tmux that will allow us to run the farmer. So we're going to do tmux new-s farmer. And now we're inside there. And then we can just run our farmer, farmer.sh. And permission denied. Oh, chmod plus x farmer.sh. The green always helps me out, because I'm like, that doesn't look right. All right, let's give it a run. Okay, so it looks like the command ran. Everything seems to be working. Q to devices. So it says devices 0, but that just means the device, it starts at 0. So there is one GPU detected, which is why CPU plotting was disabled due to detected faster plotting with GPU. We should do some benchmarks next. It does take a little bit of time for it to boot up. And then what's going to have to happen is then the piece cache needs to sync. So it could take a little while. With the CLI, I believe currently the default is 1% of the total space is used for the piece cache. So luckily, Taurus is small, so there's not a huge amount of blockchain history to download, which means that I probably won't need to worry about it taking too long to sync the piece cache. Now it does say like plotting sector, but you're not going to see progress for a little while. And I have a 3080 Ti for this, so I would expect it to actually plot pretty quickly. You can see some other logs get print. So you can't scroll in here, which is kind of a pain, but I think you can do Control B and then yeah, and then the little bracket there, and that allows you to scroll in tmux. So you got to learn the little commands if you're going to use tmux, but this usually works pretty good. But we can see it did the benchmarking, it identified the disk, so 15.4 TB or terabytes, actually probably 14 TB. Everything is looking good. So we should see it, so it's synchronizing the piece cache now. And then I think you can do Q. Yeah, Q brings you back and you can see, okay, 0% piece cache. Now, the cool thing about tmux is we can do Control B and then D to detach and just kind of clear that out. So we've got our node running, so tmux attach-t node. We can see we are fully synced, 12 peers, kind of low, but we're on the Taurus testnet, so there's not a lot of peers. Control B, D, and then we can do tmux attach-t farmer, and we're back in, and we can see we've already got 2% of our piece cache because there's just not a whole lot of it. So what's going to happen is this is going to fully sync the piece cache. Then I should start seeing the sectors get plotted. It's weird. Maybe they'll start plotting before I totally finish synchronizing the piece cache, but I've typically seen it fully sync, then they start to plot. But that is how you set up your farmer. It will connect to your node, and then once this piece cache syncs, you'll start plotting. And once you start plotting, you can immediately start earning rewards. And once you're fully plotted, then you just have to wait for the replots. So if you don't know, as the blockchain history grows, every once in a while you're going to have to replot sectors. It's typically not too bad when the blockchain history gets larger because it's kind of like the percentage of new blockchain history that's created is equivalent to the number of new sectors you need to plot. So as the blockchain history gets larger, it grows by a smaller and smaller percent because it's so big, and then you have to replot less and less. So in the beginning, when the blockchain, like when mainnet is launched, you're going to be replotting a lot, but after 6 months, couple months, your replotting is going to go down pretty significantly. So that will be it for the Ubuntu CLI Farmer Guide. Hopefully it was helpful. If it was, please leave a like, and I will see you in the next one.